we take a look at our first example, we see that this inequality tells us that x is between the two values 1 and 4, and you should be familiar that these additional little bits on our inequality signs means we're allowed to include the numbers 1 and 4. So when we're asked to find the integer solutions to this inequality, it's all of those whole numbers between and including 1 and 4. So in this case, you should be able to see our integer solutions for x would be 1, 2, 3, and 4. There are no other whole numbers in between those numbers that we haven't written there. So they're the integer solutions to that inequality. Now, unfortunately, they won't always stay that easy. So we're going to have another look at an example here that's slightly more complicated. And this one is 7 less than or equal to 2n, which is less than 12. Now, you'll notice on this one, we don't just have the letter in there on its own. There's actually a 2 in front of it. Now, we can only write down our integer solutions when we have that letter on its own in the middle of the inequality. So the first thing we need to do is to get rid of that 2 that's in front of the n. Just as if we were solving an equation, we do the opposite of what's being done to remove it. So if this is 2 multiplied by n, we're just going to divide through by 2. And that means we're also going to divide these two numbers by 2 as well. So 7 divided by 2 gives us 3.5 or 3.5. I will end up with n in the middle of my inequality, and that will now be less than 6. So all I've done is divide through by 2. It's now much easier for us to see what our integer solutions are. Now you can see from this part of the inequality, we are allowed to include this number here, but you should all see that this is not an integer because it's not a whole number. So this means that n has got to be bigger than or equal to 3.5, but less than 6. So have a think about what those numbers are. Well, bigger than or equal to 3.5, the next integer I would come to after 3.5, if I'm going up, would be 4. Think to yourself, can I have the number 5? Well, yes, I can, because it's still between these two numbers. Now, can I have 6? We'll take a look at our inequality here. There's no additional line there, so we're not allowed to include 6 as part of our integer solutions. So there are, in fact, only 2 integer solutions to this inequality. Right, so the final example we'll look at is this one here. And you'll see that also within our inequality, there's slightly more going on this time. We have 3p plus 1, and that is less than 7. So once again, we can't find our integer solutions until we have the letter p on its own in the middle of that inequality. So let's take it step by step. The first thing we want to remove is that plus 1. And we always do the opposite to remove it. So we're going to subtract 1 throughout that inequality. If I subtract 1 from minus 5, it will give me minus 6. Put in our inequality sign. If I've subtracted 1 from here, I'll just be left with 3p. And then finally on my right-hand side, 7 subtract 1 gives me 6. So I'm getting closer to having that p on its own in the middle. How am I going to get rid of that 3? Well, at the moment, it's 3 multiplied by p. So if I want to remove it, I need to divide through by 3. So dividing through the inequality by 3, minus 6 divided by 3 gives me minus 2. I will now be left with the letter p in the middle on its own. And that is less than, or 6 divided by 3 will give me 2. So now I can find all of my integer solutions, and hopefully it's nice and easy now for you to recognise the integer solutions that satisfy this inequality. Our values for p would be minus 2, because remember that inequality shows us we're allowed to include that number, minus 1, 0, and 1. We're not allowed to include 2 as an integer solution, and hopefully you can see why, because we don't have the additional line on our inequality there.